there's something transcendent about knowledge and the fact that you can get knowledge. So Socrates has said, you know everything, you just don't know you know it, so you got to remember it and recollect it. And if you have a good teacher, maybe they can lead you step by step and you can find it. That's how I'm going to get out of this sophistry or postmodern problem. He would have said postmodern if he was around today, this sophistic argument. And Socrates says, it's no easy matter, but I'll try to please you to the utmost of my power and show this is the case. Suppose that you call one of your numerous attendants that I may demonstrate on him. Certainly, come hither, boys, says Meno. He is Greek and speaks Greek, does he not, says Socrates. Yes, indeed, he was born in this house. He speaks to the boy. Attend now to this question. And you'll see how carefully attend now to the questions which I ask him and observe whether he learns of me or only remembers. Meno says, I will. Tell me, addressing the boy, do you know that a figure like this is a square, he says. That's not much of a square, but you can imagine that I drew a square there. I'm just not going to play with the whiteboard to figure out how to draw squares. Okay, so Socrates etches out in the sand, hey, look at this. You know that that's called a square, right? And the boy says, I do. And you know that a square figure has these four lines that are all equal to each other, right? So let's just define it that way so the drawing doesn't have to be so good. And the boy says, certainly I know that. And these lines, which I have drawn through the middle of the square, are also equal, right? If I go like this and I go like this, then, you know, this one must be the same as this one. Isn't that right? And the boy says, yeah, sure, obviously.
It's also really important to emphasize that the boy didn't have formal mathematical training. He only knows how to speak Greek.
Yeah, that's absolutely correct. Hey, look at that. We got a square. What if we were to do that? All right, so you know all these sides are equal, and you know that these two lines here must be equal to each other as well. And the boy says, yeah, obviously. Come on. I mean, I'm not stupid. I can see that. It's pretty clear. And Socrates says, a square may be of any size, right? Right? I could have drawn a big square or a small square, right? You could have a square of any size. And the boy says, yeah, sure. You could have lots of squares. And if one side of the figure was 2 feet and the other one would be of 2 feet also, how much would the whole be? I mean, let me explain. If in one direction of space you're going 2 feet and in the other you're going 1 foot, the whole would be 2 feet taken once, right? And the boy says, yes. And he says, but since this side is also 2 feet, then it's 2 feet twice, right? So you've got 2 feet squared, 2 squared, right? So the area of this first square would be 2 squared if this was if this was 2 feet, right? This one would be 2 feet also. So you'd have 2 feet in this direction, and then you'd move that 2 feet twice in this direction, and you'd have 2 squared or 4 as the area. Fine. And the boy says, yeah, I follow. But since this side is also 2 feet, you have it twice. And he says, yep, you sure do. Then the square is of twice 2 feet. And he says, yes. Now, how many are twice 2 feet? Count them for me. And the boy says 4. So he comes in and he looks at this and he says, yeah, I've got 1 foot here and 1 foot here. And I'm going to drag that through 1 foot here. So I've got 1, 2, I'm going to drag it through again, 3, 4. Oh boy, look, I got the answer. The square is of 4. Fantastic. I'll take away all these extra etchings. Okay. We know we've got the area. Fantastic. 4, Socrates, he says. Socrates says, and might there not be another square twice as large as this and having like this equal sides, like a square ought to have, right? And he says, yeah, sure, I can imagine that would be the case. So here we go, and we'll just say, what if I drew one twice as big in both directions? Something kind of like that. Okay, and he says, you know, you can imagine a square that big, right? And we'll just take one of these lines here, and we'll just say 1, 2, 3, 4, and we've done the whole thing all over again. And the boy's like, yeah, of course you can have a square of any size. Why are you asking me such stupid questions, Socrates? He says, yeah, I'm with you, buddy. And he says, and how many feet would that be? What's the area of this one? He says, well, it would be 8, says the boy. The boy's like, obviously it would be 8. I mean, this one was 4. That was the area equals 4. And we just made one twice as big. So I say the area must be 8. 8 is twice 4. He's wrong, obviously, right?
Yeah.
Socrates says, okay, try and tell me the length of the line which forms the side that doubled the square. I mean, this one was 2, right? So what would this one be over here? And he says, well, certainly it would be double, Socrates. Right? So this must be a side of 4. And this must be a side of 4, as this is a side of 2 and a side of 2. And so Socrates is not telling him that the answer is 8 or that the answer is not 8. He's just saying, let's talk it out together and tell me what you think. Clearly, Socrates, it's double. Do you observe, Meno, that I am not teaching the boy anything, but only asking him questions? And now he fancies that he knows how long a line is necessary in order to produce a figure of 8 square feet, does he not? He says, yes. And does he really know? And Meno says, certainly not. He doesn't know. He thinks he knows. He thinks if you draw a square with a side of 4, you're going to get an area of 8, because that's twice as big as the side of 2, where you got an area of 4, but he's wrong. He only guesses that because the square is double, the line is double. And Meno says, yeah, that's probably what he's thinking. Observe him while he recalls the steps in regular order. To the boy, he says, tell me, young man, do you assert that a double space comes from a double line? Remember that I'm not speaking of an oblong, but of a figure equal in every way and twice the size of this. That is to say, of 8 feet. And I want to know whether you still say that a double square comes from a double line. And the boy says, yes. And Socrates says, but does not this line become doubled if we add another such line here? And he says, certainly. So we got one line and we got another line. And 4 such lines will make the space containing 8 feet. He says, yes. Let us describe such a figure. Would you not say that this is the figure of 8 feet? And the boy says, yes. And are there not these 4 divisions in the figure, each of which is equal to the figure of 4 feet? Aha. So now he says, look, check it out, buddy. If I cut it in half, and I cut it in half again, isn't that the case that each of those, wouldn't you say, is the same as, isn't it the same that that's this one, this one, this one, this one? I mean, that's how we drew it to begin with, right? I mean, I might not have drawn it to scale, but the whole idea is that I drew this as twice as long as this side here, and then this one is the same, and then another double. So I really have 1, 2, 3, 4 times the area of this square, not twice. And the boy says, true. And is that not 4 times 4 instead of 2 times 4? He says, certainly. And 4 is not double. He goes, no, indeed not. How much? Well, it's 4 times as much, says the boy. Therefore, the double line square has given a space not twice, but 4 times. Is that what you're telling me? And the boy says, yeah, that's what I'm telling you. I'm telling you that if you drew a square out of a line that's twice as long as the other square, you're going to get an area that's 4 times as large, not twice as large. But remember, the boy didn't seem to know that 2 seconds ago, and Socrates didn't tell him that that was the case. He just asked him, explain to me what I've got here. Isn't it the case that this is twice as long as this? Yep. And isn't it also twice as long this way? Yep. And isn't it the case that we could fit 4 of these into here? Yep. So when you draw a square of twice the size side, you get 4 times the area. And the boy's like, yeah, that's right, Socrates. 4 times 4 is 16, is it not? Right. So it's not 8. Okay. So we finally got it. So now the boy is like, yeah. My first answer was wrong. The area is probably 16 on this one, not 8. And then Socrates asks a further question, because so far you might just say, well, this is pretty elementary. He says, what would the size of the line have to be if I wanted to draw a square that was twice the area of this first one? How could I figure that out? What line would you give a space of 8 feet if this was 16? You see what I mean? And the boy says, yes. The space of 4 feet is made from half this line. Yes. Good. So is there not a space of 8 feet, twice the size of this and half the size of the other? The boy says, certainly. Such a space, then, will be made out of a line greater than this one, but less than that one. So he's asking him. He's not telling him. He's just saying, isn't it the case that this one's 4 and this one's 16? So whatever line we're looking for has to be longer than this line, but less than double this line. So something longer than this, but less than this. And the boy's like, yeah, that's a good place to start. We've got boundaries on what we're looking for now. Very good. I like to hear you say what you think, he says to the boy. And now tell me, is not this a line of 2 feet and that of 4? He says, yes. Then the line which forms the side of 8 feet ought to be more than this and less than that. He says, it ought to be, says the boy. Try and see if you can tell me how much it will be. And the boy guesses 3 feet. All right, 3 is more than 2 and less than 4. Of course, he's wrong again, right? We know that if it was 3 feet, the area would be 9 and not 8. So good guess, though. He's guessing 3. 3 is bigger than 2 and less than 4. Socrates says, okay, if we add a half of this line to it, right? So he's going to take his old, let's do this. Let's grab this quickly. He's going to take this one right here, and we could do this with a compass and a straight edge. It'd be a lot of fun. But he's going to cut this line in half. It's easy to bisect a line, and he's just going to add another one of those halves to it and say, okay, well, then that would make this a 3. So I'm going to go ahead and make a square out of that. And there you go. And this is the one that the boy is telling me is going to have an area of 8. And of course, that's not correct because he's guessing. And so he seems not to know. And that makes the figure of which you speak. He says, yes, okay, so, but if there's 3 feet this way and 3 feet that way, and then it's 3 feet dragged out 3 feet in the other spatial dimension, so it would have to be 9, right? And the boy says, that's evident. How much is 3 times 3? He goes, 9. Now, how much is double 4? 8. Darn, we missed it again, says Socrates. I still don't know how long this line will be. And the boy's like, it wasn't 3. It's less than 3. Then the figure of 8 is not made out of the line of 3. And he says, no, it's not. But from what line? Tell me exactly. And if you would rather not reckon, try to show me the line. Indeed, Socrates, I do not know, says the boy. So the boy doesn't think he knows. Do you see, Meno, what advances he has made in his powers of recollection? He didn't know at first, and he does not know now. What is the side of a figure of 8 feet? But earlier he thought he knew. And now at least he knows that he doesn't know. Wow, he figured something out, right? So he's learning quite a lot. He thought he knew, double the side, you'll probably double the area. Oops, I was wrong. And now he knows he was wrong. He's learning quite a lot. He answered very confidently as if he had known and had no difficulty. Now he sees the difficulty. Neither knows nor fancies that he knows. True, says Meno. Is he not better off knowing his ignorance? All right, this is Socrates is actually telling Meno. And what's interesting about the dialogues is that you get to see the way Socrates is with everybody, because there's other individuals who interact like Anytus here, who comes in later in this dialogue. There's other individuals or Euthyphro, right? Some people are like, I don't like the way Socrates talks. He pisses me off. I like telling everybody I knew things, and he's making it look like I don't, and I don't want to feel ignorant. And so they plot to murder him, or they run away in shame, or they do whatever. What Meno does is fall in love with Socrates, and Socrates with him, and they have great conversations. And Meno says, okay, I now am aware that I don't know as much as I thought I did. How do I live? And Socrates says, just like that, just knowing that you're now closer to enlightened because you don't actually know as much as you thought you did, but you know that you don't know as much as you thought you did. And we can keep the good conversation going forever, and we can get closer and closer to the truth all the time, just like this boy is with geometry. Let's continue. If we have made him doubt and given him a little torpedo shock, have we done him any harm? I don't think so, says Meno. We have certainly, as it would seem, assisted him in some degree of the discovery of the truth. Now he will wish to remedy his ignorance, but then he would have been ready to tell all the world that double the space comes from double the side. And Meno says, true. But do you suppose, so he's teaching the boy geometry, but he's teaching Meno how to live in ignorance and how to say, I'm happier saying I don't know than pretending I know when I don't. But do you suppose that he would ever have inquired or learned or fancied what he fancied he knew if he didn't realize he was ignorant and didn't fall into that perplexity that everybody's trying to avoid? And Socrates is saying, just live in the perplexity with me. Let's acknowledge we're perplexed. We now know more than everybody else because they're perplexed. If they'd ever think about it when they're wrong, they think they know things. We know we don't. That's great. I think not, he says to Socrates. Then he was better off with the torpedo's touch. He says, I think so. Mark now the farther development. I shall only ask him and not teach him, and he shall share the inquiry with me. And do you watch and see if you find me telling or explaining anything to him. So we'll read it slowly. That's the challenge. Let's see if Socrates sneaks in some teaching here instead of eliciting his opinion. Tell me, boy, is not this a square of 4 feet, which I have drawn? So I drew a square of side 4 right here. Bada bing, bada boom. I'll now draw another square equal to the former one. Yes. And a third, which is equal to either of them. Sure. Suppose that we fill up the vacant corner. Very good. Here we have 4 equal spaces. Yes. Okay. Boom, 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 boom. Here then are 4 equal spaces. And now how many times larger is this space than the other? 4 times. But it ought to have been twice only, as you will remember. Sure, that's what we're looking for, says the boy. And does not this line reaching from corner to corner bisect each of these spaces? Okay, so look, I've got over here, I've got 1, 2, 3, 4. What if I were to cut this one in half, get rid of half of it, and maybe cut this one in half, maybe cut this one in half, and maybe cut this one in half. So what if I've got 8 as the area over here, but now I have half of 8. You know, I've got half of this, half of this, half of this, half of this. So now this inner square here might be a 4 because it's half of the 8. So if I cut them all in half and add them up, they used to all add up to 8, but I'm only going to add up half from each one. And the boy's like, yeah, that sounds pretty good. Let's cut them all in half. If we got 8, I'm sorry, if we had 16 and we cut them all in half, we might get our 8. But it ought to have only been twice only. So, hey, let's cut it in half. We got 4 times. Let's cut them in half. We'll get 8. Does not this line reaching from corner to corner bisect each of these squares? Yes, it does. And are not here 4 equal lines which contain this space? That's true. That makes a square because they're all equal. This one's the same as this one. I mean, I'm not drawing it to scale, but you can understand if I had. And the boy says, I don't understand. How much is this? I don't get it. Well, has not each interior line cut half of the 4 spaces? This one cut this one in half, and this one cut this one in half, and this one cut this one in half, and this one cut this one in half. He says, didn't each one of these lines cut 1/4 of our too big square into a half? And he goes, yeah, that's what each line does. How many squares are in that section? 4. How many is this? 2. How many is 2 times 2? He says twice. And this space is of how many feet? Of 8 feet. And from what line did we get this figure, this square in here? Well, we got it from the diagonal, from this right here. That's it. From the line which extends from corner to corner of the figure of 4 feet? He asks, and the boy says yes. And that is the line which we have learned to call the diagonal. And if this is the proper name, then you, Meno's slave, are prepared to affirm that the double space exists in the square that is formed with the line that is the length of the angle of the smaller square. Isn't that correct? And he says, yes, I do know that. So within seconds, the boy is like, I know that for sure, because you asked me each of these questions, and I realized that these are all being cut in half. What do you say of him, Meno? Says Socrates. Were not all these answers given out of his own head? Yes, they were, all of his own. So Socrates knows the answer, but all he has to do is ask questions, and the boy can get it wrong. He says, show me a line that I should make a square out of to get it twice as big, and the boy gives the wrong answer, 4. And he says, well, doesn't that mean we need something smaller than 4 and bigger than 2? And the boy says, yes. He says, well, what should we do? And the boy says, 3. I think 3 does it. It's bigger than 2 and smaller than 4. And Socrates says, okay, let's see if that's true. Let's just ask questions about it and see if it's true. And all he does is say, isn't that 1, 2, 3 by 1, 2, 3? And doesn't that make 9? And the boy says, yeah, actually that makes 9. I don't know why I said 3, because that's clearly not right. He says, okay, what should we do? Well, this one over here was twice as large as we wanted it to be. What if we cut it in half? By cutting each one of the 4s in half, we would know that we had an area of 8, which is what we were looking for. So now we know that we need a line this long. But what is that line? Well, that line is the diagonal of the original square. And so Socrates says, so isn't it the case, Meno, that if anybody asks you to draw a square with twice the area of another square, you can tell them, I know how to do that. take the diagonal of that smaller square and make a square out of that. That'll be twice as large. So the boy didn't know, but then it turns out he did know. What he needed to do, according to Socrates, was remember that he knew. And in order to remember that he knew, he needed to talk to a nice person who was willing to ask him questions about what he thinks until he realizes himself that his other answers are wrong. And then he goes, I don't know the answer, which to Socrates is brilliant, because before you were an idiot running around saying, I know the answer. And that's much worse than going, gosh darn, I don't know the answer. And what's even better is to share the inquiry with someone until you ask enough questions to realize, oh yeah, here's the answer. It's staring us in the face.